Hello everyone. Our project's development of composite plastic materials for microplastic to create dog-leg splints. Our members are I'm Banari Tongpoon, Ms. Thanathorn Lipong, Ms. Natamon Skuni. Our advisor is Ms. Mesawang Pongpamoon, and our co-advisors is Mr. Pranupong Shinabu. Did you know that we are currently consuming microplastics or plastics smaller than 5 millimeters as much as a credit card per week? This is slowly destroying ourselves and shows that microplastics are major problems that need to be addressed quickly.
The problem of microplastic can clearly be seen by the impact it has on living organisms. Plastic debris can entangle aquatic animals, impairing their growth and mobility, and in some cases may lead to death. When ingested, certain plastic particles can cause bioaccumulation within the organisms, and studies have detected from 7,700 to 190,000 nanogram per gram of microplastic concentrations in dog feces. Moreover, microplastic have been shown to induce cellular death and inflammation. The research has reported high level of microplastic in individuals diagnosed with cystitis, which is a disease of bladder inflammation. The microplastic also impacts the environment in several ways. Approximately 8 million tons of microplastics end up in the ocean each year. Around 32% of them accumulates in soil and freshwater resources, changing the habitats of living organisms and cause biomodification in food chains.
And all of that plastics problems leads to light up our ideas about the dog leg splints, because these days dogs are one of the most famous pets in the world, and also these splints also have very big problems because it's very expensive and also cannot adjust to be the perfect shape for your dogs.
Our project mainly used two types of plastic, the PE, which is the polyethylene, found in gallons and plastic bags, and the PP, or the polypropylene, found in plastic bottles cap. The structures are as presented on the screen.
And here are our objective, hypothesis, independent variables, dependent variables, and control variables. Next, here is our materials, equipment, and chemicals.
In terms of microplastic collections and cleaning procedures, we use 25 micron storage bags to collect microplastic from the canals, and then we filter it. Then we add various chemicals to remove organic matters, and then we filter it again, and lastly we bake at 60 Celsius for 3 hours, and then we finally get cleaned microplastic.
For our plastic collection and cleaning procedures, we start by setting up collection points for commonly used waste around the school, specifically the HDPE and PP plastics. Then we wash the collected waste with soap and water and sort it into the type that we need. Now we obtain the clean plastic, which were cut into smaller, easy-to-note pieces. For the making of composite plastic, the clean microplastics are closely separated using a stereo microscope based on the physical properties to free them from contaminants. Then we use the FTIR to analyze the composition and proportion of the microplastic, then combine them with large plastic pieces. The fiberglasses are at the ratio of 0%, 5%, and 10%. Now we analyze the material compositions to identify the suitable ratio for strength and durabilities, and finally, we use the material to make a custom-fit dog-leg sprint. In a material property analysis, we test for three types of forces: the compressive and the tensile forces were obtained from the tensile and compression test using the universal testing machine, where we use the Sharpie test to find the impact resistant force.
For our test samples, we have 4 formulas that we have tested, in which we have mixed fiberglass in different ratios of 0%, 5%, and 10% to study the strength of the mixed plastics. The detailed values are shown in the tables. And this is our result. Compression test, modulus of electricity and compressive force, tensile strength, and lastly, impact test, impact resistance. To discuss, usually a modulus of electricity between 1 to 3 gigapascal is comparable to flexible and lightweight plastic. For tensile strength, materials such as rubber, silicone, and some plastics such as PE have a tensile strength between 300 to 1,200 pounds per square inch, which means it is lightweight plastic. Materials with an impact resistant value approximately 6,000 kilojoule per square meter can withstand impact very well. They are often used in applications that require strength and toughness, such as sport equipment and safety helmets. The results show that combinations of microplastic and fiberglass give different proportions of the materials, with a tendency to increase the strength of whole materials. After considering all the value, we can see that the formula with 5% fiberglass gives the best value of making the dogleg splints.
To create the dogleg splints, we need to find the dog at the models and we measure its weight and length by the figure shown in the slide. Then we design it by the on-shape programs and print it out by 3D printers. And by these molds, we shape the composite plastics in the splint shapes and then we try it on the dog. And we are not forget to measure the satisfaction by prepare the question to ask the dog owners, observe the dog behaviors and any abnormalities so we can work through the analysis. Here are some videos of the dog behavior. And here's our information from our observations and asked from the dog's owners. She thinks that the dog benefits from the leg splint is 8 out of 10 because the bones and joints are somewhat locked, but the dog still walks with slightly difficulty. And she thinks its active level is 10 out of 10 because it's still active as same as before. And on the happy scale, she thinks it's 7 out of 10 because it has some slightly difficulty walking. And good snail is have no skin sores.
The result of the experiment is that we can find the right ratio of plastic and fiberglass that give different strengths, and we have chosen the type that is made with 5% fiberglass to make a dogleg splint that is effectively and cheaper than the market. Our experiments also show that mixing microplastic and waste plastic with fiberglass can greatly increase the strength of the materials. Our project is therefore an effective and sustainable approach to reduce plastic waste and microplastic. Remember that in the future, a livable world will not only be a world full of technologies and inventions, but it's a world where the environment is preserved. So let's protect our world together. Thank you for your attention.